Hi and welcome to this on maths prediction for the OCR Higher GCSE Maths Paper 1 for May 2018. Enjoy! Hi and welcome to this on maths prediction. So what we're going to do in this prediction is go through a predicted paper for the upcoming exam. Now what we mean by predicted paper is what we've done is gone back through the two exams that have already been sat for this, June and November last year, and we've picked out topics we think will come up again, and we've also picked out topics that didn't come up again. We've also looked through all the literature released by the exam board so that we can have a look at what they're hinting at will come up. And they've dropped some hints so far about certain aspects of this paper, which we've picked up on and put into this predicted paper. Now, this is, I think, the third year we've been doing predicted papers, and I say this every single year, and I hope that people are listening, which they clearly are, I hope. This predicted paper is not a be-all and end-all. Please don't use this as this is my one thing I'm going to do for the exam. I don't think anyone does, but I'm going to say this anyway. Use this as a revision strategy, just like you'd use a revision guide and anything else. It's a good way of just testing how your revision's going. And what a lot of people last year did was they did the test, had a go at it, see what they got, and then did the test a couple of weeks later to see if they've raised their grade. And just regularly doing the assessment will help you judge kind of what grade you're at. Now we construct these papers so that they're balanced by topic. So it's the example would say what percentage of each topic should be on the paper. We also balance them by assessment objective, basically difficulty of question. So they're balanced between AO1, AO2, AO3. If you know what that is, then brilliant. If not, don't worry about it. They're also balanced about grade. So the example would say roughly how much of each grade. They give it categories, but they're balanced along those. So it's an accurate paper in that regard. There are some questions that involve drawing and things like that we can't do perfectly, but hopefully we do it in a way that you definitely know how you'd use a compass or a protractor if you were asked to do that physically on paper. Now, those of you who've done predictions with us before would know that this entire paper is available on our website completely for free for you to try, and you can do it online. You can even register to save your scores, so you can have a go at the paper, come back a week later and remember what you got and see if you can beat your score. The website and this video will keep track of the grades as we go on, and on the website it shows you what grade you're at so far, and the difference between what your grade is and the maximum amount you could have got on the paper so far. So it's a really good tool to kind of judge what you need to do to get a grade 4, 5, 6, 7, 8, 9, whatever grade that you're looking for. The website also includes loads of other stuff. I'm not going to be able to go into all of it, but we've got topic busters are the main ones, which is every single topic at the new GCSE, and you can just go through and practice any topic you like. We've also got demon questions, which are the hardest exam paper questions. I was talking about assessment objectives earlier. These are AO3, which is the hardest ones. They're problem-solving questions generally, and they're the ones that students struggle with the most. So we've got demon questions that you can just practice the hardest ones. Now, obviously, there's lots and lots and lots more on the site, so please check the site out after you've watched this video. We also have a supporters club, which comes with a few extra perks. Obviously, everything on the site is for free, but one of the perks we're looking at including, and probably have by the time you watch this video, is a PDF download of some of the papers, including this paper. So if you want to consider supporting us, please check the link that's probably come above my head right now. So if you like this video, please click like. If you don't, obviously click unlike, and please consider subscribing. We're going to release the paper 2 and 3 papers just after paper 1 for paper 2 and just after paper 2 for paper 3. Those are more accurate predictions because obviously we can take off the topics that have already come up. I hope you enjoy this video. Thank you. Right, so you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box. And there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator's set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These two zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. So, inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So, x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, X says here x is greater than minus 7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's if it's greater than minus 7, then it can't be minus 7. It can't be equal to it. So it's going to be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the minus 7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this minus 25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40. 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 5s are 50 and 4 5s are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900. That's 21 with a 0. So 900 plus 21, 210 even. 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37. Take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want two children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit and let's do the total. So the total is going to be the adult price, which is this one here, plus the two children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben, and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a liar. A liar has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a liar's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha's only got Christine left to play after we counted all the other matches. And Christine's matches have already been counted so far. So we've got the 4 matches a liar's going to play, 3 matches that William's going to play, not counting the one we've already counted from a liar, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total, there are 10 different matches going to be played. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. 2 minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. The important thing to remember with an estimate question is that you don't get any marks for getting the exact answer. So even if this does come up on a calculator paper, then you won't get any marks for getting the right answer. It wants you to estimate. Normally, that means to round everything to one significant figure. Now there are some exceptions to that. Square roots are an obvious one. If you've got root 82, you won't make that, I should put squiggle lines, you won't make that root 80, you'd make that root 81, because then you'd be able to say, well, that's roughly 9. Anyway, there are some small other exceptions. So let's go through this and let's convert these all to one significant figure. And if I draw some lines in, then that might help me. The line for the first one will be between the 7 and the 3, so that will just be 7. For the next one, the line will be after the 1, so that would be 200. Ooh, switch that back. Get all in the same colour, so that would be 200. Now this is where some people make mistakes. They think that will round to 0, but significant figures ignore any zeros. It's the first non-zero digit you start counting. So the line will go after the 4. So that will round to 0.5. Okay, now we can times the tops together, or times the two numbers at the top together. So 7 times 2 is 14, with 2 zeros, over a half. And all we can do here is just times the top and bottom by 2. So I can times 14 by 2 to get 28. So 1400 times 2 is 2800. And the bottom times 2, well, that's just 1. So the answer is just going to be 2800 or 2800. Now the point of estimation is you should be able to do it in your head. You have to write down the working out still, but the point of estimation in real life is when you don't have a calculator. So if you're finding something that you've got to do a little grid or something, or work it out a long way, then chances are you haven't estimated enough. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1 over 4, or a quarter. Okay, so this question, it Looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be Ka, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah, blah, blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. And we're going to take away the 123 because that's what we don't want. So on a calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100%, and they went down 12%, what we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got so first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals. So this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. So there are two things going on here. Varies and inversely are two things you need to look out for. Varies could be is proportional to, or whatever. It could say it that way, or it could just say varies. Now the first thing to write down when it says y varies, or y is proportional to, is do this little fish sign, alpha sign, and that means it's proportional to. Now when it says inversely, it means that it's going to be proportional to 1 over x. The next thing to do is get rid of that fish sign and replace it with an equals, and the way of doing that is just times the right hand side by k, which is a constant, so it's k over x. Now it says when y is 15, x is 14, so we can put those values in to find out what k is. So 15 equals k over 14, and we times both sides by 14 to get k equals, and so we've got 15 times 14, which is 210, equals k. So the formula will be, we sort of go back to this one, the formula will be y equals 210, which is the value of k, over x. The next question says find the value of y when x is 10. So y is going to be 210 over 10. That's nice and easy. That's going to be 21. And then it says find the value of x when y is 6. So we're going to have the equation we've written earlier. So it's going to be 6 equals 210 over x. And what you can do here is you can times both sides by x and then divide both sides by 6. And whenever you've got a one number on this side and a bottom of a fraction, you can actually just switch them over by doing that. So it's x equals 210 over 6. So 210 divided by 6 is going to be 35. Okay, so box plot question. Now, it might be tempting to think that the information here is all you need to plot on the box plot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other two that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is 22. There we go, and that's our box plot. So that's question 1 done, or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students, so I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5, that doesn't make much sense. So on this question, I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down because you've shown that it's 17.5 where you can't get half a student. So let's go for 17 or let's go for 18. What's interesting in this question is there's no amount. So what we can do it in two ways really. You could put an amount in, and it doesn't matter which amount you put in. So normally students go for £100 and then see how long it takes to get to £200, and that's absolutely fine. But you don't need to put amounts in. You can just work with the percentage that you've got. So how are you going to do that? Well, first of all, you've got to convert this percentage into a multiplier. We're going to start off with 100%. Compound interest is money you get, so it's going to increase by 5.8%. So that means that we're going to end up with 105.8%. To make that a multiplier, you just divide it by 100, so it's 1.058. So that is our multiplier. So year one, our multiplier is going to be 1.058. So 1.058. So we've increased it by 5.8%. To get year twos, all you need to do is 1.058, which was year one's multiplier, so after a year, and just times it by 1.058 again. And so I get 1.119364. Well, if you have a look at this bit here, it means it's increased by 11.9%. Well, we're looking to double the money, so we need it to be a 2 point something. So we keep going, and something you can do is you can press on the calculator answer times 1.058. And if you press equals, it will give you year 3, which is 1.184, blah, blah, blah. But all you need to do on the calculator is press equals again, and it will just do the times 1.058 to the previous number. So 1.252, so year 5, 1.325, blah, blah, blah. So it's going to take a while. 1.40. Let's scroll down a bit. So number 7, 1.48, 8 years, 1.56, 9 years, 1.66, 10 years, 1.75, 11 years, 1.85, 12 years, 1.967, blah blah blah. So we're getting close. And 13 years we get 2.081, blah blah blah. So 13 years is going to be our answer. Now there's a few things just to note here. The first thing is that students tend to try and divide. They try and see how many 5.8s there are in 100 or whatever. Don't do that, because compound interest grows each time. So in the 5.8%, if you look at the numbers here, these numbers are increasing and increasing each time, and that's the beauty of compound interest. That's why people say save early. Start saving as soon as you're born. The second thing to note is you might be looking at it thinking, really, do mathematicians do that? Do they just have to sit and write them out? Well, no, actually there are other ways of doing it, but at this level, at GCSE, this is the method to do it. Okay, so whenever we're asked to find an inequality or draw an inequality onto a graph, always draw the line but without the inequality in it. So instead of x is greater than or equal to 5, always draw the line x equals 5. If it can be equal to it, it's a solid line. If it can't be equal to it, it's a dashed line. Okay, so it's x equals 5, and I'm going to draw a solid line. So where does x equal 5? Well, x equals 5 here, and here, and here. And in fact, anywhere along that line, it's just a vertical line up, and that's the line x equals 5. And it's really important to remember which way around it is. Whenever you have x equals something, it's always a line from top to bottom. When you have y equals something, it's always a line from left to right. Okay, that's the line x equals 5, but it asks us to mark the region in the inequality with an r, so it's either going to be to the left or the right of this line. Well, it says that x can be anything that's greater than or equal to 5, so x could be 5, 6, 7, 8 on this graph, okay, because obviously it only goes up to 8. So anywhere this side of the line is absolutely fine, so I'm going to mark my R there. And actually sometimes the exams ask you to shade it in, so I just shade in that right hand side of the graph. Sometimes you shade in what you don't want, and if I was shading in what I didn't want, obviously it would be on the left hand side of that graph. The easiest way I've found to work with bounds is just draw a number line, put the number that you've got, so we're looking at x, put the number you've got in the middle, try and figure out what the next number down would be. So the next number down would be 1.1 if they're rounded to the nearest one decimal place. What's the next number up? Well, it would be 1.3. So the next thing to ask yourself is, where's the cutoff point? What stopped it from being 1.1? Why did it round to 1.2? So the lowest it could be is halfway between those two numbers, which is 1.15. So that is our lowest bound, lower bound. The upper bound, the higher bound, would be here, which would be 1.25, but we're not asked for that. So 1.15 is the cutoff point. Now this is a slightly harder question in B because we're given this formula here. Now we've got to be careful when we're using formulas. We're looking for the upper bound of t, so we're looking for t to be as big as possible. Well, for t to be as big as possible, x needs to be as big as possible because we're adding it and we want a number to be big that we're adding. But the bigger y is, the smaller that fraction becomes. So we want actually y to be as small as possible. If you ever think about it, the fraction a half and the fraction a third, which is bigger? Well, a half is bigger. So the smaller the number at the bottom, the bigger the fraction. Anyway, a little bit of a side note, but that's really important that you remember that if there's a denominator, that we want it as big as possible to make the smallest possible number, or as small as possible in this situation to make the number as big as possible. So we need to find the upper bound for x and the lower bound for y. So using the diagram I drew earlier, 1.25 is the upper bound. Now you might say to yourself, well hang on, no, technically 1.25 would round to 1.3. Okay, let's delve into that a little bit. The actual answer should be 1.249 recurring, but there's two reasons I've not written that. The first reason is that it's a pain to work with. Typing that into the calculator would be a pain. The second thing is that actually 1.249 recurring is the same as 1.25. They are exactly the same number. Now if you don't believe me, a little bit of a side note, a third is 0.3 recurring, 2/3 is 0.6 recurring. Following the same pattern, 3/3 would be 0.9 recurring. But we know 3/3 is the same as 1. So 0.9 recurring is the same as 1. There is no difference, and that's very difficult to get your head around. Anyway, side note over. So the upper bound of x is 1.25. So we need to do a little number line to get the lower bound of y. So it's 4.6. So the next one down would be 4.5. So the cutoff point is going to be halfway, which is going to be 4.55. So that's going to be our lower bound, 4.55. So to find the upper bound of t, we need to do 1.25 plus 1 over 4.55. So let's just do that on the calculator. 1.25 plus fraction button 1 over 4.55. And I get the answer 1.46978 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1.47 because that 9 would round that 6 up. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2. And we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is, on the Casio calculators, you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it, and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x, and the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach which I'm going to use is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it x, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine x over, so this is sine x, this is x here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine x equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So x is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that x is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as y, just to make it a bit easier. So y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that y is 31.2104 blah blah blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. Where's A and B? A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now that's why you must show you're working out, because if you got say 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of a function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean that it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC, and you can write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51, and the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees, and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so I need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, 180 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB. And this time we're using the circle theorem that says angle at the centre, which is the 150, is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees, and again it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3.
With graphic transformations, anything that happens inside the brackets is going to be affecting the x coordinates. So what we're doing is we're taking away 2 inside the brackets. Now, when it's inside the brackets, it goes the opposite way around to what you think. You think take away 2, I take away 2 from the x-coordinate. Actually, you add 2 to the x-coordinate. So the new point will be at 0.66 because I've added 2 to the x-coordinate. So a minus moves the graph right and a plus moves the graph left. Just try and remember it's the opposite way around to what you think. Anything outside the bracket will mainly affect the y. So that 2 there for question B will be affecting the y. It will basically stretch it out so that the y coordinate will double. The intercept will actually stay at the same points. So we've got the x coordinate's the same because that hasn't been transformed, but the new y coordinate is going to be 12 instead of 6. There are a few different ways of answering this question. The easiest way, especially for the way this question's set out, is to count the squares. So first of all, let's have a look and see what range we're doing. We're doing from 10. So from 10 to 40. So we need two things. We need to know, first of all, how many big squares, and we might as well count big squares there are between those two, 10 and 40. And we need to know how many there are in total. So let's just have a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 tools. So that's going to be 22 in that rectangle. That's going to be 10 high. So that's going to be 10 big squares. 1, 2, 3, 4, 5, 6, 7. So that's going to be 14 big squares. And this little section here is 1, 2, 3, 4, 5, 6. So I can use a calculator if it's on the calculator paper. So let's add those together, and that's going to be 52. So there's 52 in total in that middle region. But we need to know how many big squares there are in total. So we're going to count the other ones. So 1, 2, so that's going to be 6, so that's going to be 12. And that's the same height, so that's also going to be 12 because it's 6 and 6. So we're going to add the two 12s on. So there's 76 altogether. So total is 76. So it says it wants it to 2 decimal places. So it doesn't want it as a fraction, because as a fraction it's 52 over 76. So 52 divided by 76 is going to be 0.6842 blah blah blah. So that's going to be 0.68 to 2 decimal places. Now what you could have done is worked out the areas of each of the bars to get something that's maybe proportional to the frequency and then done it that way. But if you can count the squares, it's just much easier and quicker. And sometimes you've got to sort of count half squares or little squares and find a way of doing that. But that's absolutely fine. When you're working with proportions, the actual amounts don't matter. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something, okay? Now, we've got 2x squared, and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here. So it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x,
but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it. That's completing the square. Okay. So I'm going to replace that with what I've just found out that it is x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences, we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator, you can just do 25 take away 13. If it's on a non-calculator paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, I'll write 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we've got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50.
I hope you enjoyed that video. If you like what you see, please click subscribe, and then you'll get notified on all the content we put out. Also, check out our YouTube channel. We've got all the topics in the Maths GCSE collated by grades, by topic, by tier. We're finding that it's really useful resource. I think we've got hundreds and hundreds of videos. They're tiny little videos on each tiny little topic, which students are finding useful. Don't forget to check out the website as well. Everything on the website, all the online papers, everything we put out on the website is completely free. And also don't forget, if you really like what you see and you want to support the site, please click this link now above me, and that will take you to the supporters club. Thank you very much.